Swayam Prabha. Digital India. Educated India.
Hello everyone, today I am going to deliver a lecture on welding induced distortion. So, this is the content of today's lecture. That means first I will discuss about introduction of welding induced distortion, then type of distortion, then effect of material properties on distortion, then effect of welding procedure on distortion, and at the end of this lecture I will discuss about control of welding distortion. That means I will discuss different types of methodology by which how we can control the residual deformation, or you can say welding induced distortion. First of all, we should know what is distortion. Distortion is such a phenomena. Once in a structure it happens, then what happens, the structural shape changes, you can say. That is why what we can say, distortion can be you can say defined as any unwanted physical change or departure from its specific shape and size in a fabricated structure or component due to welding is generally termed as distortion. So, what we can define distortions? So, we can define distortion as any unwanted physical change or departure from a specification in a fabricated structure or component due to welding is called distortion. So, this distortion generally complicates further fabrication. It decreases the life cycle of the structure, as well as it also deteriorates the aesthetic appearance of the structure. That is why to control this distortion and prediction of this distortion is very much essential. So, in this course I will discuss how to control and what is the cause of this distortion and how we can predict this distortion in details. Okay. So, first of all we should know what is the cause of this distortion. Mainly the cause of the distortion in a structure is due to welding, especially during welding due to non-uniform heating and cooling. There is occurs some non-uniform expansion and contraction phenomena. Due to this non-uniform expansion and contraction phenomena, generally this welding structure changes required shape and size. Okay. Due to this, the different types of distortion shape come in welded structure. So, apart from these things, due to the support provided during inside the structure, they are generally develop some sort of internal stresses. Due to this internal stresses, the shape and size of the structure changes from its original shape and size. Due to that also there will come some distortion. Apart from this thing, distortion is dependent on the material properties which we generally use to make the structure. It is also dependent on what types of welding procedure we are going to use to fabricate the structure. So, it has different types of cause of this distortion. Now, I will discuss one by one in detail. First of all, I will discuss what are the different types of distortion. Broadly, we can categorize the distortion into a welding structure in 6 different categories. One is called transverse sinkage. Here you can see transverse sinkage. What is transverse sinkage? Transverse sinkage means, you see, this is generally welding direction and this is perpendicular to the welding direction, you can say. So, this welding direction is called longitudinal direction. Longitudinal direction and transverse direction, this is called transverse direction. Perpendicular to the weld line is called, this is actually weld line. Weld line. Okay, the perpendicular to this weld line is called transverse direction. Transverse direction. Now you see the distortion which is occur perpendicular to this weld line direction, that is here you see initially the plate shape was, this is the original shape of the structure, this is the original one you can say. So, after welding, due to the contraction, after solidification, due to the contraction of this weld material, what happens, there is occur some sort of contraction of this, or you can say shrinkage of this original structure, or you can say original plate. So, due to this what happens, the shape or size changes. So, it is initially the solid line represent original shape. So, after shrinkage, this is the final shape. So, due to this you can see there is occur some sort of distortion along the transverse direction, along that means this much of shortening, you can say this much of shortening is taken place, this much of you can say shortening is taken place. This much of shortening is taken place. So, this shortening is taken place in which direction? It is occur generally perpendicular to the welding direction, that means along the transverse direction. That means the width of the plate, if it is butt welding, if the width of the plate decrease, you can say. Why it is decreased? Because during solidification in weld zone there occurs some contraction phenomena. Due to this contraction, both weld zone as well as near the base material, due to heating, and after heating, once it solidifies, there occurs some contraction types of force. Due to this contraction force, it generally transverse shrinkage is occur. This transverse shrinkage you can call one types of distortion, which is called transverse shrinkage. Now, another one is called longitudinal shrinkage. So, you see these types of shortening also, another shortening also can occur whose direction is along the longitudinal direction, that means along the line of along the direction of line of welding, that you can say, generally which is termed as longitudinal direction, which I have already told earlier. So, these types of longitudinal shrinkage also can occur due to this shrinkage of this weld material, correct? Because once the weld material solidify, it create huge shrinkage force, or I am telling that means its volume generally decrease. Due to this decreasing of this volume, what happens, there occur huge shrinkage force. Due to this huge shrinkage force, there can be a shortening of the longitudinal length. So, that is called longitudinal types of shrinkage. So, you see this solid line represent the original plate before welding. So, after welding, this dotted line generally phi line shape become this dotted line which I am showing. So, you see these types of shrinkage which is occur along the longitudinal direction of the weld, you can say, is termed as longitudinal shrinkage. There can occur some other types of distortion, that is called rotational types of distortion. What is rotational types of distortion? Here you see rotational types of distortion generally occurs once we do we start welding from here, okay. So, this welding generally creates some shrinkage types of phenomena, okay. So, this generally shrinkage as well as you can say during heating it create expansion, but once it solidify or cooling, then what happens, it generally shrink. Due to this shrinkage force, the plate can generally come closer to each other. What I am telling, understand? This plate can come closer to each other. So, this is a phenomena which is rotational types in nature, you can see. Due to this shrinkage force, what happens, initially it was straight. So, due to this welding solidification, what happens, there is a chance to rotate this two plate, and what happens, close this root gap. What I am telling, understand? So, that types of phenomena or that types of distortion is called rotational distortion. So, here you see rotational distortion how it is. Here you see this solid line represent original shape of the plate. After the rotation of this plate, you see this front portion generally come inward direction. Here you can see this. So, final shape is this representing as dotted line here. Okay. So, these types of distortion is termed as rotational types of distortion. Now, another distortion which is called angular distortion. Angular distortion means what happens, due to this initially the plate was like this. So, once we do the welding, then you can see we know this welding plate mid thickness zone is generally welding plate mid thickness zone we can termed as neutral axis, which is very well familiar to you. So, neutral axis is such a zone where the bending stress is 0, which is very well familiar to you. I am not going in details about this thing. Now, due to this welding, you know that here you see this weld bit. Once you see the weld bit shape, you can see top side of the weld zone, whatever the volume of material is there, this volume of material generally is more than this bottom side of this neutral axis weld material. Okay. So, let us this bottom side weld material I am defining is zone 1, and this top side weld material zone I am defining as zone 2. So, you can see the volume of weld material zone is much greater than volume of what is called weld material zone at zone 1, that is below the neutral axis zone. Now, once it solidify, once this material solidify, then this volume of molten material loss, or you can say weld material loss higher generally in top side, this will create some shrinkage force. So, shrinkage force you can say is proportional to this volume of material solidification. What I am telling, understand? So, higher the volume of material solidification, higher will be the shrinkage force. So, about neutral axis if you will see, so at top side you will get a shrinkage force, let F2 I am representing. Top side due to shrinking of volume of material at volume 2, and bottom side also there will be a shrinkage force, so direction will be like this about neutral axis you can say. That means bottom side force I am representing F1. As this volume of material is varying through the thickness you can say, that means about neutral axis it has higher volume of molten material, and lower the neutral axis it has lower volume of molten material. So, due to these things what happens here you can see, due to shrinkage of this volume of molten material, generally here you can see the shrinkage force at top side will be much higher than bottom side. Okay. So, once it is solid, it generally create a force on top side will be higher due to high volume of material than the bottom side of this neutral axis. So, due to this high shrinkage force, once it solidify, this and top side force is more, as it is more, that is why this plate is generally bent and it create a angular types of shape. You see here I have shown. So, initially the plate was horizontal, but after this shrinkage force or variation of this volume of material, generally it create a angular shape. So, we are getting here a angular types of geometry, you can say theta. So, this types of deformation is termed as angular deformation. This you should keep it in mind. And there can be another types of distortion which is called buckling distortion. This buckling distortion generally occur due to the combination of different types of distortion which I have told, what I am telling, and especially this buckling distortion is occur in case of thin plate. And what happens if the length of the weld, you can say if the length of the weld in case of a thin plate is more than its critical length of buckling, you can say, then what happens, there is a chance of buckle of this plate. That means buckling phenomena, you are well familiar with this thing, because during shrinkage time there is occur some sort of shrinkage types of force. Due to this shrinkage force there is a chance of longitudinal types of shrinkage. What I am telling, understand, due to this longitudinal types of shrinkage, and what happens due to this thin section and lower critical length and higher critical length of this plate weld length, or you can say there can be chance of buckle of this, what it is called, buckling of this thin sheet or a thin plate. So, the buckling means it is failed due to this shrinkage effect, especially due to this longitudinal types of shrinkage effect, that you can say. Okay. So, due to this thing generally there is occur some sort of, or you can say combination of this shrinkage effect and length of weld and thickness of the plate, generally you can say these types of buckling phenomena is occur. You should always keep this thing in mind. To happen a buckling types of deformation or the buckling types of distortion, the plate length, or you can say weld length, should less than the critical length of that thickness of the plate. So, for different thickness of the plate, you can use different length of what it is called, length of weld. So, you always keep this thing in mind. Once you go for thin material types of welding, there you should do your welding at a time lesser length of weld compared to higher thickness of plate. What I am telling, understand? So, these types of buckling phenomena is depends on thickness as well as length of the weld per run, you can say, per run in the sense per a single time, you can say. So, continuously, that is why continuously we should not do welding for a long length, because once we do the long length for a particular time, that means at a time, then there is a chance of crossing the limit of buckling critical length. So, once we cross this critical length, then there is a chance of what it is called, due to this shrinkage force and all, there is a chance of buckling of that plate. So, depending upon the thickness, this length you can vary. So, higher the thickness, higher the length of weld at a time you can do. There is a limiting length is there that you can get from what it is called classification rule book. So, different rule book are there. Once you follow that rule book, you can get the idea. Now, another types of distortion which is called bending distortion. This is also a distortion where the plate generally bend, whose shape become like this. Okay, what I am telling, understand? So, these types of bending distortion occur especially when there is a particular amount of longitudinal types of shrinkage. But this is particularly occur in case of longitudinal types of shrinkage effect. This you can say. So, once longitudinal shrinkage force and goes some limit, then there is a chance of bending of that plate. What I am telling, understand? So, what happens? The shape become like bend shape of this plate like this. Now, there is another types of distortion which is particularly seen in case of very thin types of plate, which is occur by combined effect of this transverse longitudinal types of deformation. So, once in a structure due to this combined effect goes some critical value. So, in that case there is a chance of twisting types of change of the original structure. So, this is termed as twisting types of distortion. So, twisting types of distortion occur due to the combination of transverse, longitudinal and rotational types of different types of distortion phenomena combined together. There is a chance of twisting of that plate structure. Now, I will discuss what is the effect of material property on distortion. First up, I will discuss. After that, I will discuss what is the effect of welding procedure. Then I will discuss how we can control the distortion. So, first of all, we should know what should be the material property affect the distortion more, you can say. Generally, here one thing you should keep it in mind, lower the thermal expansion coefficient, lower is the distortion of that structure. This you should keep it in mind, because you know higher the expansion, higher the contraction, higher will be the distortion, correct. So, we know this higher the thermal expansion coefficient means length, you can say increment of length per unit temperature per unit length. So, if this thermal expansion coefficient generally its unit is per degree centigrade, you can say its unit is per degree centigrade. So, if this thermal expansion coefficient is more, then higher will be the thermal expansion. So, higher will be the thermal expansion, higher will be the thermal contraction. So, higher will be the thermal contraction, higher will be the deformation or distortion in that structure. That is why lower the thermal expansion coefficient of the material is preferable, because lower the thermal expansion coefficient, lower will be the distortion. Then another property which is called high thermal conductivity. High thermal conductivity also have a effect to decrease the what is called thermal gradient. So, once there is a reduction of thermal gradient, then what happens, there is a chance of, you can say there is a chance of reduction of distortion. Because what happens, if the thermal conductivity is high, thermal conductivity high means heat can dissipate or heat can conduct very easily. So, it will not be remains in a particular place for long time, that you can say, because the unit of thermal conductivity, you know, watt per meter Kelvin. You can say thermal conductivity means if the thermal conductivity high, then heat can conduct quickly. What I am telling, understand that if the heat can conduct quickly, then there is a chance of less thermal types of gradient, that you can say, that can at a very quickly heat can spread out on, and then thermal conductivity can that means thermal gradient can uniform throughout the length, what I am telling, understand. But if the thermal conductivity is less, then what happens, this heat cannot actually quickly conduct. Due to that things around the zone there is occurs some high thermal gradient. So, once there is a high thermal gradient, then what happens in different zone, different types of expansion contraction will be taken place. So, where the more temperature is there, then there will be more expansion, say surrounding there will be generally less temperature, because there is less chance to conduct the heat due to this low thermal conductivity. So, there will be less expansion or contraction. Due to this phenomena, what happens, there can occur high deformation. That is why here you should keep it in mind, lower thermal conductivity types of material provide generally you can say high distortion. So, to get less thermal distortion or to get less distortion in a structure, our structure should have high thermal conductivity. This you should keep it in mind. Now, lower melting point temperature generally lower the temperature range of that welding operation, you can say. So, lower the temperature range in this welding operation, then what happens, lower will be the residual stress, lower will be the, you can say, deformation, that you can say. That is why what happens, melting point also have a effect on what it is called deformation, because once melting point of a material is high, you have to provide more heat. So, more the heat to raise the more temperature, correct. So, more the heat provide in a structure, more will be the thermal expansion and contraction. So, more will be the chance of deformation. That is why lower the melting point of the material, lower will be the residual stress, as well as lower will be the deformation. This you should keep it in mind. Now, you see another material property which is called mechanical property, you can say. So, whatever the thing earlier I told, that you can say physical or you can say thermal property. Now, we will discuss mechanical property. Mechanical property like Young modulus, then yield stress, what its effect. So, you see Young modulus also have a effect on thermal distortion. Here always you should keep it in mind. Generally, whatever the stress level developed in a welding structure, that stress is generally within a range of yield stress level. So, higher the yield stress of a material, higher will be the stress developed in that structure. So, higher will be the stress developed in the structure, higher is the chance of deformation. This you should keep it in mind. Okay? That is why lower the yield stress, lower will be the residual stress developed, you can say, residual stress developed in the structure. So, once lower will be the residual stress developed in the structure, then what happens, due to this lower stress level, the deformation or you can say distortion development also less. Then another property is called modulus of plasticity, or you can say Young modulus. It has also have a significant effect on weld induced distortion. It is observed that it generally stiffen the plate. The higher the it acts as a stiffness types of characteristics. That means it provides some stiffness in the structure. So, here one thing you should keep it in mind, higher the modulus of elasticity, higher will be the stiffness of the structure. So, higher will be the stiffness of the structure, lesser will be the what it is called deformation, because if the structure is more stiff, then what happens, the chances of deformation also will be less. So, this you should keep it in mind. So, what are the things we observe? Here you can see generally lower thermal conductivity, lower melting point, lower yield stress, these provide less deformation, as well as high thermal conductivity and what is called high modulus of elasticity generally gives, or you can say high thermal conductivity and high modulus of elasticity. So, high thermal conductivity and high modulus of elasticity give less distortion. This you should keep it in mind. Now, what is the effect of welding procedure and processes, that also we should know. Now, we will discuss about what is the effect of welding procedure and welding processes in welding distortion. in details in this slide. So, welding procedure have a significant effect on welding distortion. Here one thing you should keep it in mind, a suitable welding procedure is usually determined by the productivity and quality requirement rather than the need to control distortion. What I am telling, understand? So, generally a welding procedure is determined based on what? Based on productivity and quality requirement. These also you should keep it in mind. But another requirement is also there, need to control the distortion. That is why it is observed that welding procedure have a significant effect on welding distortion. How it is? Here the general rule for selecting a welding procedure to prevent the angular distortion or distortion, we should follow this following types of aspect. Okay. So, welding process should be such so that the deposit the weld metal as quickly as possible. So, it should deposit the weld material as quickly as possible. That means, the welding process should be as fast as possible. So, it is possible once the speed of the welding is high, correct? And the welding should provide a concentrated types of heat source, that also give less deformation or distortion in a structure. This is another point. Now, in case of welding, we should use least number of runs to fill the joint, because we are going for joining a thick plate, So, in this thick plate, generally to do the welding, we should require different types of pass of welding. Okay. So, this is called multi-pass welding. Okay. Because to fill this gap, there is required different types of pass of welding. Just I am showing. Let this is 1 pass, 2 pass, 3 pass, 4 pass, 5 pass, 6 pass, like this. Now, you see, what does it tell, this third point? Third point tells use the least number of run to fill the gap. That for thick types of section, we should use as much less number of run as possible, because higher the number of pass, higher will be the chance of doing the welding, that means hitting that zone multiple time, correct? Higher the number of hitting time. So, higher will be the thermal expansion and coefficient, higher will be the thermal expansion and contraction. So, due to this higher thermal expansion and contraction, due to the more number of run, there is a chance of more deformation. But if you use less number of run to do this thick section, say instead of let us 10 run, if you can reduce it to 5 run or 4 run by using some thick or you can say larger diameter electrode, or you can say optimum diameter electrode, then what happens? You can control the distortion significantly, because if the number of pass increase means in the plate zone multiple time you are using same heat source, but if the number of the positioning that same heat source less, then definitely your heat input will be less. Lesser the heat input, lesser will be the expansion contraction, lesser will be the distortion. This you should keep it in mind. Okay. Now, for a multi-pass welding, generally this 1, 2, 3. So, what happens after first run, you have to do second run. So, you see in fourth point I have written, keep the time between run to minimum. That means, after a first run, when you should start the second run. So, for that also some optimum technique is there. So, as minimum as possible will be the time between this 2 run, your deformation also will be less. This you should keep it in mind. Now, another things also, once you go for doing fillet, you can say fillet as well as butt weld, size of the volume of material is a important aspect. This you should keep it in mind. Now, let us in a volume of in a fillet types of joint, let us in a fillet types of joint, here one things you should keep it in mind. In case of fillet types of joint, we have to fillet joint means it is a triangular shape weld. So, this is generally called fillet weld, triangular shape. Now, the distance from this to this generally it is called leg length, and this is also another leg length. So, this is also another leg length. So, depending upon this size of the leg length, generally welding size is defined. This you should keep it in mind. So, what happens, higher the leg length or higher the size of the welding, higher will be the volume of material expansion and contraction, higher will be the what happens chance of distortion. So, that is why what happens in this fifth point I have written, keep the weld to minimum specified size. That means as minimum as possible will be the leg length, but we should have sufficient strength in that welding structure, correct. That is why we should optimize this leg length. So, it is observed that the leg length should be within a range of around thickness of the plate, within a range of that, because there is some rule book is there. So, once we follow the rule book, there you will get all the details for different types of thickness, what should be the leg length, what should be the throat thickness and all the thing, that idea you will get. But as minimum as will be the fillet size, your welding deformation and distortion will be less. This you should keep it in mind. Now, use balance welding. This is also another very important aspects of this welding process to control distortion. Okay. So, use balance welding about neutral axis. What does it means? Like for this thick section in this welding, if we do here double sided types of welding, if we do here by double sided welding. So, we know this double sided welding. So, our bead will be like this. Here you can see. So, you know this is called neutral axis of this plate, this is called neutral axis of this plate, you can say. So, in this thick section types of plate, if we do the instead of single V welding, if we do this double V welding, then what happens here, generally we can balance the, let us what happen this types of first run, other side we do the second run, then this side third run, fourth run, like this. So, if this way we do the balance types of welding, so instead of single V welding, if we go for double V types of welding, and if we do because this double V welding means it is balanced about this neutral axis. So, you see this is the neutral axis. So, top side and bottom side the weld material and its sequence also balanced. So, once we do the balanced types of welding about the neutral axis, then our deformation will be less, because one side will affect other side. That what I have already shown in earlier slide, there I have shown about neutral axis how the sinkage force is coming. So, in top side anti-clockwise types of force is coming, bottom side clockwise types of sinkage effect is coming, correct. So, these two force generally if it is equal, you can say, then what happens, your deformation will be minimized or nullified, that you can say. So, once this sinkage force top and bottom side if we can balance, then what happens, we can minimize this residual distortion, correct. So, that is also possible once we do the welding about neutral axis by balanced way. So, what I am saying, instead of doing the welding in one side, if we do the welding in both side, then what happens, that gives less distortion. This also you should keep it in mind. Now, here I have already written some very important point of this effect of welding processes and procedure, like weld metal should be deposited using large diameter electrodes. That means we should first optimize the diameter of electrode. That means higher the diameter of the electrode, higher will be the chance of less number of run for a thick types of section of weld. So, that is why what happens, we should optimize this diameter of the electrode, but what happens, there depending upon the current range and machine capacity, we cannot exceed beyond some range of the diameter, because higher the diameter, lesser will be the current intensity, you can say. Because what happens, that is why what happens, machine also have some capacity, as well as, so depending on this machine capacity, we should choose our diameter of the electrode. So, diameter of the electrode should be as large as possible, that gives generally less number of run. So, less number of run will provide less amount of heat input. So, due to this less heat input, what happens, you can say we will get less expansion and contraction phenomena, as well as we will get less distortion. This you should keep it in mind. That is why here I have written as large as possible the diameter will be that gives less distortion, because it provide less number of run. And also you should keep it in mind, during welding process, once we increase the current range, then what happens, we can say penetration also increase. So what happens here, instead of widening this weld bit, here generally penetration depth is increased. Due to this penetration depth, increment of this penetration depth, you can say, so there will be less variation of this weld material deposition through the thickness. So lesser the variation of weld material deposition through the thickness, lesser will be the what it is called distortion. This you should also keep it in mind. So high current, high diameter electrode is generally preferable for a welding process. Another point here I have written, as heating is much slower and more diffuse in case of flame types of welding, especially oxyacetylene, or you can say fuel types of welding, gas welding process, where generally we use a torch. Once we use this torch generally spread the heat in wider zone. So wider zone material is expand and contract. So once this wider material contract during solidification, at that time generally due to this welding by using this oxy-fuel gas welding technique, generally due to this wide range of heating zone, there is a chance of wide expansion and contraction and more deformation than arc welding process, because in arc welding process there we can guess generally localized or concentration types of heating source. So for that what happens, the volume of material expansion and contraction in case of arc welding is less than this gas welding technique. That is why in gas welding techniques more deformation or more distortion we get than arc welding process. Okay. Now this mechanized the techniques combine this high deposition rate as well as high welding speed have the greatest potential for preventing the distortion. This is also very important point, you should keep it in mind. So instead of manual welding, once we are able to do it by some mechanized means, in case of automatic welding with high deposition rate and high welding speed gives less distortion. If in a welding structure it will not provide any restraint, so without restraint in a welding structure, the welding deformation is dependent on what? We can say it dependent on joint geometry, weld size and number of run, which I have already told you. Okay. So higher will be the weld size, mean leg length, or you can say width of the weld bead in case of butt welding. Okay. Then higher will be the chances of expansion and contraction, and higher will be the distortion, as well as number of run if it is increased. So number of time of heat, same heat you are applying more time. So what happens, more heat will be input in the plate. So more the heat, more will be the thermal expansion and contraction. So more will be the chance of distortion. This you should keep it in mind. Okay. Now here I am going to show in details this control of this welding distortion. Here first of all I have already told you, so that things here I am summarize. After that one by one other different types of technique which are generally commonly used, to control distortion, that also I will discuss. So first of all, what I have told you, for controlling of distortion we know that more the metal placed in the joint, greater the contraction force will be during solidification. So always keep this thing in mind, we should use as minimum as weld material as possible, but what happens, we should use such amount of weld material so that our requirement should fulfill, that means it should have sufficient strength. Okay. And another things also I have already told you, number of weld pass should be as few as possible, because more the number of pass, more the heat, more the resultant shrinkage. So due to this more will be the distortion. So and then third point also I have already explained that weld should be placed near the neutral axis, which reduce the distortion. This is also another problem. Okay, so that is why instead of single V you can do double V. Another things you can get here, that balance around the neutral axis welding also gives less distortion. This also little bit I am explaining. What is this balance types of welding? We are just going to do a T joint. So instead of single side T joint, this is one side, once we do the welding, this is called single side. Instead of single side, if we do both side of this flange, you can say this is called generally flange and this bottom one is called wave. So, both side of this flange, if we do the fillet welding, then what happens, it generally gives us a balanced types of phenomena. Okay. Due to these things, in these types of T-joint, generally we will get less deformation. So, instead of one side fillet welding, if we use both side fillet welding simultaneously, then what happens, we can get a balanced types of welding. Okay. So, here the distortion or sinkage force generally balance each other, and what happens, here the distortion is minimized. Now, this is the sinkage force generally can be balanced by opposing the force like other sinkage force, what I am telling, understand. Just now I have already explained, and also we can control the distortion by restraining forces imposed by clamp, jig and fixture. That means by some extra holding device that generally hold the plate rigidly, you can say. That holding device have different name, like one is called clamps, jigs and fixtures. So, by using this jig, fixture and this clamp, we can control the distortion significantly. But here one of the drawback of these types of clamp, jig or fixture or restraining is higher the restraining in a welding structure, higher will be the residual stress, because that which I have already explained in my residual stress course or residual stress lecture. Now, another things also you should keep it in mind, to control distortion, always preferable to do welding in downhand direction. That means welding should do whenever possible in downward direction. Okay. Now, another things also you should keep in mind, that is called weld outward from the center also have significant effect on welding residual deformation control. What does it means? Like what happens, let this is a plate. So, that also I will discuss in details in the subsequent slide. There is some welding, different types of welding sequence and how it control the distortion. So, here this point which I have written. So, welding outward direction means so you start from middle and do the welding outward direction. This is outward direction, this is generally outward direction. So, these types of welding also have effect on welding distortion control. Okay. That point I have written here, that weld outward from the center point have a effect to control distortion. Now, another thing, this is also I have already told you, quick welder prefer to avoid greater volume of adjoining metal expansion due to heat. So, what I have told you, quicker the welding procedure, then what happens, only this lesser will be the heating of the surrounding material, correct? Because in a particular place, if a heat source is put for a long time, then due to the conduction, surrounding material will be more heated. If it is very fastly moved, then what happens, the heat will be less time there will be, so less amount of material will be heated due to conduction and other things. Okay. So, less material will be expand and contract, so less will be the distortion. That things here I have written, that means quick welder prefer to avoid greater volume of adjoining material expand due to heat. Now, another point also you should keep it in mind, to control distortion, another point, larger weldment are broke down into sub assembly. So, instead of doing very large welding at a time, make it a small part and do the welding, after that you assemble together. That means a big structure you first divide into a small component. In this small component, first you do the welding, after that this small component welded part you joint one by one. That is why there is some steps are there. So, generally step, sub assembly, assembly. So, these types of different types of steps are there. So, from at plate, with this plate we have to put the stiffener. After that, this once a stiffen plate is made, then this stiffen plate you have to connect together to make a sub assembly. Then different sub assembly you combine together makes a big assemble part. What I am telling, understand? So, that is why we have to divide the big structure into a small part and do the welding in this small part. After that, this small part combined together will give us less deformation rather than making the full structure and do the welding in this very big structure at a time. Now here I am going to show control of distortion by different types of practical techniques, like the control of distortion may be achieved in one of the following way, like the use of different types of joint design can control the distortion. How it is, that I will discuss in subsequent slide in details. Then offsetting the joint to be welded also have a effect on controlling the distortion. How it is, that also I will discuss in detail. The use of balance welding techniques, which I have already told in earlier slide, but in details I will now discuss in subsequent slide. The use of clamp, jig and fixtures also have significant effect to control distortion. How it is, that also I will show now. Now first of all, here you see the use of different joint design. So here you can see, if we just make the weld V groove in wider angle, then here whatever the volume of material will be required, here you see, if the angle is more, then the volume of material required is more, as well as what happens here, top side about this neutral axis, you see about this neutral axis is top side volume of material, and bottom side volume of material also will vary significantly. So here the angle of V, higher will be the variation of this volume of material above neutral axis as well as below neutral axis, as well as due to this high V angle, more will be the volume of material there. Due to this high volume of material and high variation of this material distribution through the thickness, there is occur high expansion and contraction. That means how high sinkage force is generating there. So there is occur more angular distortion, more sinkage, longitudinal sinkage, more transverse sinkage. What I am telling, understand? That is why you see, once we reduce this V angle to let us 40 degree or even 0 degree, then what happens, we can control the distortion significantly, because in this 40 degree you can see here the volume of material requirement will be less, and through the thickness the volume of material, this top portion volume of material about neutral axis also is less variation than this bottom side volume of weld material, correct. But if the angle is 0, that is called, this has a specific name, this is called a square barred joint. What it is called? A square barred joint. So in case of a square barred joint, here what you can do, if we do the a square barred joint welding, here you can get a weld bed which is more or less through thickness uniform in nature. So about neutral axis, whatever the portion of volume will be, volume of molten material will be top side, the portion of volume of molten material also almost same below the neutral axis also. So due to this, whatever the sinkage force, that means F1 force and F2 force will be developed, for this case it will be more or less same, and as the volume of material requirement in case of a square bar is less, due to this thing what happens, there is a chance of less distortion, both longitudinal sinkage as well as you can say angular types of deformation. Okay, that things here I have shown here. You see, in case of 60 degree it is very high distorted on, in case of 40 degree it is less, and if in case of 0 degree or a square bar it is almost nullified. You can see it is almost horizontal in nature. So next lecture I will start from here. There I will discuss in detail about offsetting the joint to be welded, the use of balance welding technique, the use of clamp, jig and fixture, and apart from this thing some other techniques which are commonly used to control distortion in details. Okay? Thank you.